Hi, this is A-Level Mechanics, Year 1, Chapter 2. I'm looking at everything to do with constant acceleration. So, basic speed formula. We should know that speed is given by distance over time. And moving on from that, we've also got acceleration, and acceleration is your change in speed over time. Okay? So typically we use delta S over delta T, which basically means a change in speed divided by the change in time. Okay, this later sort of morphs into calculus into ds by dt, but I'll save that for another video. So again, that delta just means the change in. Okay. So here we want to find the velocity from a distance time graph. We want to find the velocity when t. What am I? To do this, and using briefly GCSEs, we can use a tangent. So basically, we want to do the distance divided by time because this is changing. Because this is a curve, we need to make a tangent line. So basically, you get a ruler and make a fairly big triangle, and then do distance divided by time. So here I have 9 divided by 2.5, and that will give you a rough, so using a graph, of what the speed or velocity is going to be. Next, we want to find the acceleration from velocity time graph. We're going to find the acceleration. So the acceleration is going to be the change in velocity divided by the change in time. To do this, you again can make a triangle. So I'm going to pick 2 points, make a triangle from it. So my velocity has gone down from 5 to 2. So my change in velocity was minus 3. It went down by 3. My change in time has gone up 6 seconds. So here the velocity is minus 0.5. So the acceleration is minus 0.5. So because velocity has gone down, you want a negative acceleration, also called a deceleration. So it's minus 0.5 meters per second squared. And we can also do a similar thing to find the distance from velocity time graph. We want the distance travelled in the first 7 seconds. And here the velocity as we've gone over that thing. If you want to work out the distance, that's going to be the area under the curve. If you do velocity times time, that gives you distance. So if we work out this entire area, that will be the total distance travelled. And this will just be using a formula for trapezium. So we can do half a plus b, where a and b are the start and the finish. So that will be 5 plus 1.5 times by the time travelled, which was 7 seconds. Work it out and that's your distance travelled. So these things don't come up much, but you are supposed to know how to work out the velocity from a distance time graph, same with acceleration and same with distance travelled, the basic ideas. Okay, the main thing in this chapter, which you sort of grow to sort of know and love over the years, is going to be the Suvat equations. Okay, these will basically define anything to do with motion in a straight line with constant acceleration. So it's Suvat, and that's an acronym. So S stands for displacement, basically how far you have travelled. U is the initial or start velocity. V is your final velocity. A is acceleration. And lastly, T is time. And in your formula booklets, you'll be given these 5 formula. And again, each of them work based on what things you know and what things you want to work out. I'm just going to go through a couple examples, sort of show you how you'd use them. So for this question, we have a small stone that is projected vertically upwards with a speed of 19.6 meters per second. Modern stone is a particle moving freely under gravity. We want to find the greatest height above O reached by the stone. So let's work out what we know. To do that, the best way to do it is basically to write down Suvat, and anything we know we're going to fill in, and anything we want to know we're going to put a question mark next to it. So the distance I don't know, but I do want to work it out. I want to find the greatest height reached. So that's what I'm aiming to work out. U I do know. u is 19.6. We also know the acceleration. It's moving under gravity. The acceleration is going to be minus 9.8 meters per second squared. The acceleration is negative because it's pulling it back down towards the ground. It's slowing down my particle. There's a slight trick here. We in fact do know v. If we sort of look or imagine what it would look like for a stone to go up, at its very highest point, when it's reached its highest point, it's going to stop going up, stop for a brief instant, and then start coming down. So at this point here, the velocity is 0. It's just a gap where it's gone from going up, pause for just like a brief split second, and then starts coming down again. So for the greatest height, you always want your final velocity to be 0. We have 3 things, that's enough. We want to find the fourth. So we're going to find the equation that uses these 4 letters. S, U, V and A. And if we look here, we have one of those we can use. So we can write that down. V squared equals U squared plus 2AS. We're going to fill in what we know next. V is nothing. U is 19.6. And then it's plus 2 times minus 9.8 times S, which you don't know. So let's leave that as S for now. So we can now rearrange this to work out what S is. We want to take this 19.6 squared to the other side, so become a negative. That will then equal all this stuff here. We want S by itself, so we want to divide by everything that's been times by S. So we're going to divide by 2 times minus 9.8, and that will give me S. To work this out, we can go straight to our calculator, and we can just type that in. So minus 19.6 squared divided by 2 times brackets minus 9.8, and that should work out what the greatest height is. In this case, it is 19.6. So S is 19.6 meters. So in the first part, we've worked out the greatest height. Part B, we then want to find the length of time for which the stone is more than 14.7 meters above O. So again, if we go back to our sketch, just doing something like this, we want to work out how long it's going to be above 14.7 meters. We do know the greatest height. And we can do a couple of things now. Okay, what I'm going to do, I'm going to basically count on its journey. I'm going to work out how long it's going to take me to get from here to here. So we can see that again. And again, for different parts of the question, you often need to re-sue at it from based on where you want to start. So the distance travelled, I want to go from here to here. So I want 19.6, take away 14.7. So I want to travel 4.9 meters. I'm going to start here. So my initial speed is 0. V we don't know. A we do know. A is 9.8. A is now positive because it's actually speeding the particle up. And the question says work out the length of time. So we want to know what t is. Again, we've got 4 pieces of information. That's now enough to work it out. We go to our list of formula, and the formula we want to use is going to be S equals ut plus a half at squared. Again, let's fill in what we know. We have 4.9. If u is 0, then ut is also 0, plus a half times 9.8 times t squared. Okay, you work this out, and it turns out that because a half times 9.8 is 4.9, that means that t is going to be 1. Okay, because t can't be negative. So therefore, it took 1 second to go from here to here. We want the total time. However, we should remember that everything to do with these things being thrown up in the ground, they're perfect parabolas, which means everything's reflective. So it took 1 second to go from the highest point to 14.7 meters. That means it will also take 1 second to go up from 4.7 meters up to the highest point. We're going to use a lot of sort of flexibilities for this. So therefore the total length of time it took was 2 seconds. Okay, just one more example. So these ones get quite wordy quite easily, as you can see. The best thing to do is, as it says, is make a sketch. Okay. So, two trains, M and M, are moving in the same direction along parallel straight horizontal tracks. At time t equals 0, M overtakes N whilst they're travelling with those respective speeds. Okay, we want speed time graphs, so I can start that straight away. Again, typically have some space to do this for some squared paper. It's look a bit nicer than this. But I know that M is doing 40 meters per second and N is doing 30. So here's my speed and there's my time. Okay. Train M overtakes train N as they pass the point X on the side of the tracks. Okay. After overtaking N, M maintains its speed of 40 milliseconds for t seconds and then decelerates uniformly, coming to a rest at point Y. So for t seconds it keeps its speed and then it's going to start to slow down, and it says uniformly, which is why that's a straight line, and this here is at point Y. And again, for what it's worth, here was point X right at the start. Okay, after being overtaken, N maintains its speed for 30 meters for 25 seconds and then decelerates uniformly, also going for a rest next to the point Y. Okay, this is slightly more awkward because I haven't been told whether 25 seconds is bigger than or less than t. So let's just do it randomly, see what happens. So let's say it looks like that. Okay, that's a decent guess. This is going to be wrong because we know that both the trains come to rest at point Y. And we should remember from right at the start that if you want to work out the distance travelled, that's the area under this graph. And it's obviously the area of the graph for M will be bigger than the area of the graph under N. So that means it needs to keep on going for a bit longer and then obviously come to a halt a bit quicker. So here that was 25 seconds, which is obviously going to be longer than t. Okay, that was part A. We're then given that xy is 975 meters. We want to find the value of t. Okay, let's see how we can do this. So we can work out the area of each of these. And to do that, I'm going to basically chop up the shapes and work out each area. So for train M, we have 40 times t. That's how long it's travelling at 40 meters per second. And then we've got a triangle. We then have a half times the base. So the base is this length. Okay, that we don't know. Times, and we also want the height, which is still 40. Okay, so let's colour code that really quickly. So this section is 40 times t, because that's a rectangle. This section is a half times whatever the base is, times 40, because it's a triangle. So the problem is we don't know how long it took to get this point here. However, we are told that the times taken by trains to travel between X and Y are the same. So we can work out this overall time by using the other train, train N. So let's do that now. So for train N, we have 30 times 25, because that's how long it travelled at 30 meters per second. And we then want to do the triangle part, so it's going to be a half times the base, which you don't know. I'll just call it x, times the height, which is 30. And the total distance travelled for both of them actually is going to be the same, which was 975. Hoping to see here that for train N, we have an equation we can solve. We're going to do is work out what N is. So let's do that. So first step, I'm going to take away this term here. So a half times x times 30 is going to be 975 minus 30 times 25. Again, I don't need to work this out. And then to work out x, we just divide by the other stuff. So it's 975 minus 30 times 25, and that is all divided by everything here that's not x, so a half times 30. Again, we can go to our calculator, and we can just work that out. So 975 minus 30 times 25, all divided by 15, a half times 30, which gives me 15 seconds. So x is 15, so that tells me that this little bit of time here was 15 seconds, so therefore the overall time they took was going to be 40 seconds. 25 plus 15 gives us 40. So now we can go back to our m equation, and we know slightly more about what question mark is. We know the whole time was 40 seconds. If we travel at top speed for t seconds, then this must be 40 take away t. And again, now we have an equation we can solve. So let's go through this. We have 40t. Let's clean this up slightly this time. We've got a half times 40, so it's 20 times 40 minus t, and that equals 975. So all I've done is written 40 times t as 40t, and as 20 comes from doing a half times 40. We're now pretty much there. Let's expand this bracket out. So 40t, 20 times 40 is 800. 20 times minus t is minus 20t, and that equals 975. So 40t take away 20t is 20t, minus 800 off gives us 175, and therefore t is going to be 175 over 20. Okay, which again you should calculate to work out, and that should be, who knows, 8.75. And I think that was all we needed to do. Find the value of t. Yeah, the value of t was 8.75 seconds. Okay, and that's it. Yeah, this wasn't a CVAT question, so all these questions fall into either using the sort of distance time graphs and velocity time graphs and so forth, or they fall into CVAT questions. Okay, and it's fairly obvious which one is which. Hope that helped, and thanks for listening.